This is question 3 on the page labeled 209. In question 3 part A, the line L1 in the diagram has a y-intercept of 10, which is right there. Write down its slope and hence its equation in the form y is equal to mx plus c. So we're asked to do two things in the question: write down the slope and its equation. Okay. So that point A has coordinates of 0 up to 10. Point B has coordinates at 5 up to 0, halfway between 4 and 6. So the slope then, using the slope equation, I have 0 minus 10, 5 minus 0, which is minus 2. As minus 2 is the slope, and the y-intercept is 10, I can write down y is equal to minus 2x plus 10. Those are my two answers for part A. Next, in part B, it asks, on the diagram, draw and label the lines L2 and L3, where L2 is slope minus 2 and y-intercept 4, and L3 has slope 1 and y-intercept 10. Let's mark the y-intercepts first. First y-intercept for L2 is at 4. So 0, 2, 4. And L3 is already marked at point A. Now the slope of L2 is minus 2. And rise over run, which is the definition of slope, tells me if I go a rise of 2 and a run of minus 1, that gets me my slope. Or if I did a rise of minus 2 and a run of 1, that also is my slope. Going from the point 4 for L2, point 4, if I run 1, 2 to the left, that's minus 2, and up 1, that's another point on the line L2. If I run 1 and rise 2, sorry, if I rise 2 and run 1, so rising 2, running 1, rising 2, running 1. All those dots lie on the line L2. So those dots can be joined, and the line labeled L2. So that's rise of 2, run of minus 1. For L3, rise over run can be written as 1 over 1. This means for every one step I rise, I run 1. Okay, so from the intercept of 4, sorry, instead of 10, rising 1, running 1, rising 1, rising run of 1. And any of those dots can be joined up to form the line L3. Part C asks for the area of triangle formed by L2, L3 and the y-axis. So the intersecting lines are L2 and L3 and the y-axis. So there's L2, L3, and there's the y-axis. So the triangle highlighted, I'll redraw down here. The point on the top of that triangle will be the point intersection of line 2 and line 3. The base you can see is simply the difference between 4 and 10, so the base already we know is 6. That's point A. There are 10, this is 0, 4. So I just have to find that third vertex, which will be the intersection of L2 and L3. So L2 can be written in the slope form of y is equal to mx plus c minus 2x plus 4 L3 converted in the form y is equal to 1x plus 10. Now as both of those are equal to y, the easiest way to solve simultaneously to find the point of intersection is simply let the top equal the bottom. That's minus 2x plus 4, which is y, which is 1x plus 10. That'll get me x, so I bring the x over, I get 3x is equal to minus 6, which that implies that x is equal to minus 2. Sub that back into L3, y now is equal to minus 2 plus 10, or 8. So the point of intersection can be labelled as minus 2, 8. And because this vertical line between A, 0, 10 and the point 0, 4 is the y-axis, the x-coordinate there, minus 2, indicates the perpendicular height. So area now is given by half by base, which is 6, times perpendicular height, which is 2, which gives me 6 square units.